4.3, applications of linear systems. So how do these system equations apply to real world problems? There we go. John works in enterprise, rents out cars. He rents out cars for 70 hours a day and vans for 75 hours a day. He rents out 40 vehicles and makes $28.80. How many of each do you rent? Okay, first off, you want to define your variables. Doesn't matter what letter you pick. You're going to be doing cars and vans. Some people just stick with the old standard. You know, go X equals cars and Y equals vans. Some people like to go letter specific. You know, C for cars and V for vans. Do what you want to do, doesn't matter. You could do S and Q. It makes no difference. Okay, just as long as you know what letter represents what thing in the problem. That's the most important thing. Now, when you're doing these, you're going to set up two equations. And the way I like to refer to them is the number line and the value line. So the number line is going to be the number of cars, which is unknown, plus the number of vans, which is unknown, equals the number of vehicles, which is known. And then the value. Well, the value is $70 for each car and $75 for each van. Whoops, that's supposed to be a Y there. And then the total value, the money made, is $28.80. Okay? So that's the basic setup. It's very simple in the same format every time. You have your number line and your value line. And if you follow this format, these are very easy to set up. Now, at this point, you have a choice. You can solve by doing substitution, in which case you want to solve the first one for either X or Y and then substitute it in. Or you can do elimination. So it doesn't matter which way you want to go. I prefer elimination myself. I think it's a little bit faster. Not always, but it's just my preferred method. Now, you can multiply by negative 70 or negative 75 to cancel the X or the Y. I usually prefer to cancel the smaller number to avoid negatives. That's all. Not a big deal. Doesn't matter what you do. Your choice. There's basically four ways to solve this problem. Solve for X and use substitution. Solve for Y, substitution. Cancel the X's and eliminate. Cancel the Y's and eliminate. Okay? That's your choice. So what you get is negative 70X, negative 70Y, equals 7 times 4. Negative 7 times 4 is negative 2800. Okay? And so now you just add the two lines, and you get cancel. 75 minus 70. Let's clean that up. It looks like a 20. Minus 70 equals 5Y. This makes $80. And again, if I would have canceled the Y's, I would have got a negative X, but then I would have got a negative value on the other side, and when I divide by negative, it's still in the positive. It's not a big deal. Divide by 5, and I get Y equals 80. No, don't. That's just silly. I don't know what I'm doing there. I don't know how I divide. I'm not good with numbers. So let's try that again. 80 divided by 5 is 16. That's much better. Okay? There has to be 16. It can't be 80 because there's only 40 vehicles rented that day. Silly me. Okay, now I go back to my original equation. That's the easiest to plug this into. I go X plus 16 equals 40. I subtract 16 and I get 24. Now, in real world problems, this is not enough to say X and Y. It also is not enough to just do this, because we're not looking for a point of intersection. That's not what we do. This is a word problem. We need word answers. So there's 24 what? Well, X was cars. That's why we do this at the beginning. So we keep them straight. And then there are 16 vans. And that's it. Number 2, Becky went to the store for some bananas and pears. She bought a total of 20 items. $2 a piece with bananas, $2 for the pears, $2 for the bananas. She spent $53. Again, set up your values. If you want to use B and P or X and Y, makes no difference. You call X bananas or pears, makes no difference. So that's bananas, and this is pears. Now I set up my number line. Number of bananas, unknown, plus number of pears, unknown, equals how many pieces of fruit? 20. Value of the bananas, 3. Value of the pears, 2 for each one. Money spent, 53. So, I'm going to multiply by -2 because it's a smaller number. Again, it doesn't matter. So that's going to give me -2x, -2y equals -40. Add these together, and I'm going to get 1x, cancel, equals 13. Go back to my original equation. 13 plus y equals 20. Subtract 13, I get y is 7. Not finished yet. I need to look back x's bananas. So that means I got 13 bananas and 7 pears. Alright? So real quickly, I'm going to do this one again on another page. If you want to skip this, that's fine. If you want to see how it be done with substitution, I'm going to do it real quick. It won't take very long. So x plus y, again, equals 20, and 2x plus 3y equals 53. I'm going to solve this one. You pick x or y. It makes no difference. X equals 20 minus y. I'm going to take this and plug it in here for x. 2 times 20 minus y plus 3y equals 53. Distribute my 2, I get 40 minus 2y plus 3y equals 53. This should look familiar because pretty much there's y, subtract 40, 13. Plug it back in to get 7 pears. So, it doesn't matter which way you do it. They're both pretty simple methods. I just personally prefer elimination. Chris asked the bank teller to cash $390 check using $20 bills and $50 bills. So I want to call X my 20s and Y my 50s. All right? Now, they got a total of 15 bills. So number of 20s plus number of 50s equaled number of bills total. Values, pretty obvious. Value of a 20 plus value of a 50 equals the total value, which is 390. I'm going to multiply by -20 because that's the smallest number and it avoids negatives all over the place. Just my preferred method. -20x, -20y equals 20 times 15, 300. That's -300, right? Add these together, cancel. 50 minus 20 is 30. 390 minus 300 is 90. Divide by 30, and I get y is 3. Go back to my original equation. X plus 3 equals 15. X equals 12 after I subtract 3. So that means I got 12 $20 bills, and I got 3 $50 bills. Easy, breezy, beautiful, cover roll. I reached in my pocket and found $4 in quarters and nickels. There are 20 coins. How many of each are there? Again, you can use X and Y, Q and N, whatever. So X, I'm going to say quarters. You want to call them nickels? Go for it. Y is nickels. Number line. Number of quarters plus number of nickels equals the number of coins. Value of a quarter. Be careful here. It's 25 cents, so that's 0.25. Be extra careful here. The most common mistake is to call nickels 0.5. It's not. That's 50 cents. It's 0.05. So be very careful whenever you have nickels. It's the most commonly messed up coin. So plus 0.05y equals $4. So I'm going to get rid of the nickels because it's a smaller value. Negative 0.05. That's going to give me negative 0.05x, negative 0.05y equals 20 times negative 0.05 is negative $1, which makes sense because there's 20 nickels in a dollar. So 25 cents minus 5 cents is 20 cents, 0.20x. The y's cancel. $4 minus $1 is $3. And if I take $3 divided by, be careful, 0.20, x is 15. So in other words, if there was something called a 20-cent piece, 15 of them would make $3. So I go back to my original equation. I'm going to just fix that. I started to draw x. I don't know why. 15 plus y equals 20. So y is 5. Back to my original setup. X is quarters. So I had 15 quarters and 5 nickels. Okay, tickets. X is boy, Y is girl. You want to use B and G? Up to you. I'm kind of a traditionalist. I just use X and Y. So, number line. Number of boy tickets plus number of girl tickets equals the total number of tickets, which is 128. The cost for a boy plus the cost for a girl equals the total amount brought in. There you go. I'm going to use elimination. Negative 20, negative 20x, negative 20y equals 128 times negative 20 is negative 2560. Add, x's cancel. 35 minus 20 is 15y. And then 3355 minus 2560 is 795. If I divide that by 15, I get y equals 53. So I go back to my original problem. X plus 53 equals 128. I subtract 53 from 128, and I get 75. Back to my original setup. X is boys, so that means 75 boys and 53 girls. Okay. Davis Rent Car charges a fixed rate per weekly rental plus a charge for each additional mile driven. A 1-week trip of 520 miles costs $250, and a 2-week trip of 800 miles costs $440. Now, this is a different setup. Okay? This is comparing two value lines, basically. And this is the classic, if you have repairs on your car, and the parts are just a set rate, and then you pay per hour. So it's set rate plus hourly rate times the number of hours. Or if you have a repairman walk in your house, it costs $60 just for them to show up, and you charge $40 an hour. That's going to be 60 plus 40x equals the bill. So in this case, when we're setting this up, we have a weekly fee and the additional miles driven. So X is going to be my fee, the weekly fee, and then Y is going to be the miles fee, whatever, however you want to do it. Okay? So you're setting up two different situations. On the first one, a 1-week trip. And remember, this is fee per week. All right? So, a 1-week trip plus 520 miles. So 520 per mile equals $250. A 2-week trip plus 800 miles equals 440. I forgot my Y here. Sorry. Okay. So you have your 1 week, 520 miles, $250. 2 weeks, 800 miles, $440. So this would be an easy one to do for substitution. You can move the 520 over and substitute in, or I can easily turn x into negative 2x to cancel my x's. 520 times 2 is going to be 1040 equals negative 500. Okay? Now, this is one of those situations where look what's going to happen. I'm going to get 800 minus 1040 and get a negative 240y. But don't worry, because over here I have 440 minus 500, which is going to be negative 60. Now I'm going to divide by negative 240. And get 0.25. So y equals 0.25. So that's the cost per mile. So if I go back to my original equation, x plus 520 times 0.25 equals 250. 520 times 0.25 is 130. If I subtract 130, I get 120. So that means it costs $120 per week plus 25 cents per mile. So it might throw you off thinking 25 cents seems small, but remember that's per mile. So that does make sense. 25 cents times 800 miles plus $240. Or 520 times 25 cents plus 120 gives you 250. It works out. And last but not least, last problem. 6 times a number and 5 times another number is negative 32. Okay? This one is where you just basically just translate it. So 6 times a number and, which means plus, 5 times another number is negative 32. Now your next line is the difference, so you know you have subtraction, of 5 times a number and 9 times the other number is 26. Now this is one of the ones with elimination where there's no quick way to do it. You have to either cancel the x's or the y's, and you either have to cancel the x's with 30 or the y's with 45. It makes no difference. You choose. Since I already have a plus and a minus, I want to cancel my y's. It's not a big deal. I want to cancel my x's. I just make one of them negative. So the first number 9 and 5 both go into is 45. So this is going to be 9 and 5. So now I multiply. 9 times 6 is 54x plus 9 times 5 is 45y equals negative 32 times 9 is negative 288. Now 5 times 5 is 25. Negative 45y, which is going to cancel, equals 26 times 5, which is 130. When I add these, the y's cancel. 54 plus 25 is 79. And 288, negative 288 plus 130 is negative 158. by 79 and get x equals -2. So I'm going to plug that back into my original equation. Doesn't really matter which one. 6 times -2 plus 5y equals -32. That's going to be -12 plus 5y equals -32. Add 12 to both sides. 5y equals -40. Nope, 20. I don't know what I'm thinking there. -20. Divide by 5. Y equals -4. So my first number is -2, and my second number is -4. And that's it.